Hi, Creality has sent me a Creality Sermoon X1 laser scanner for review. Okay, there's one thing to note. This review sample is not new. The package inside the box may look different from your copy. Okay, so there's something used to be in this bag. Yeah, I think it's a phone holder. No, this would be the scanner. It's a bit dirty. The scan bridge is the adapter, 12 volt 3 amps. It's a very long cable. Is that it comes with the scale bar, calibration board. So this would be the calibration board from the Sermoon X1. It's a little bit larger. There is a fingerprint on the lens. I need to clean this up. Okay, so I managed to clean the lens using a lens cleaner and a microfiber cloth. And also, if you found a dust stuck on the projector, use a blower to blow out the dust before you start using it for the best performance. Some dust is fine for the lens, but smudging is not, and that is bad for the projectors. Okay, let's look at the component of this scanner. This depth camera is 3 megapixels and never been used before in the previous model. This is a cross line projectors. This is 7 line projectors, and this is a single line projectors. These 3 projectors is also new. It's never been used in the previous model before. I think this infrared projector is the same as you see on the Sermoon X1. And for the RGB camera, they didn't tell me. It looks the same, but in the test result, the RGB camera performs better than the S1. Okay, let's compare it side by side with the S1. The depth camera spacing, the X1 is a bit wider. The lens elements are different. The S1 has the front glass cover, and the X1 is no longer has that. And you can notice that the S1 is longer. This is because the S1, it comes with another pair of the depth camera, ultralight depth camera. X1 only has one pair of the depth camera. Laser projectors, they are not the same. They look different, and when I scan it, the laser line also look different. X1 is 532 grams. X1 is 507 grams. So it's a bit heavier. Okay, if you look at the back side, the buttons layout is the same. The button from the X1 is larger. Tactile, rubberized buttons. The black clip is hard plastic, same as the S1. And you can notice that they have moved the 1/4-inch thread mount to the back, because with the S1 we have a problem mounting the quick release plate. So the S1 quick release plate is not flush because the body of the scanner is curved. See here, it's not flush with the quick release plate. For the X1, so it's easier to mount the quick release plate, and it's all flush. But there is a problem. It's moving forward the front, so it's front heavy. So it's very easy to tip over. I mean, if you knock it lightly, it will just fall over. So this is very important. Be careful when you mount it on the Wi-Fi handle. For the back it's fine, for the front it's not. Okay, these are the 4 laser scanners from Creality from the past 1 year. Starting with the Raptor X. It's the first time that we see the cross-line laser on a consumer grade 3D scanner. I think they launched this in November 2024, and in February 2025 they make a cheaper version of the Raptor X, and it's called Raptor Pro. They cut down the cross line from 34 lines to 22 lines. And the speed of the Raptor Pro when scanning with the cross line is slower, 25% slower than the Raptor X, and the rest of the hardware are the same. And in August 2025, Creality released a new scanner, Sermoon X1. It's the first time that we see a single line laser scanning in a consumer grade 3D scanner, and it also adds the larger depth camera from the other light, so it makes the Sermoon S1 quite bigger laser scanner. The Sermoon S1 has all new depth camera and the projectors, so they are not sharing the same hardware component between the Raptors and the Sermoon S1. And for the precision, from my experience using it in the past 4 months with the S1, I think that the Sermoon S1 has a bit less precision than the Raptor series. And for the accuracy, I think they are about the same, 14 to 48 microns of the accuracy error when I'm scanning the small and medium sized object. So there's nothing stand out between the 3 scanners here when comparing with the accuracy. And in October 2025, we have a Sermoon X1. So what is the difference between these 4 3D scanners from the same manufacturer? So a lot of people is going to ask me which model should I get, because there are 4 of them now. So this 3 scanner here, they are Metrology grade 3D scanner. It gives a less than 50 micron accuracy error, good enough for general reverse engineering use, CNC machining or 3D printing. Metal sheet, folding, forming is accurate enough. You don't need anything more accurate than this for this kind of work. This vernier caliper has an encoder that it can reach the 10 micron step. And I have verified it with the standard block in the University Metrology lab. So this vernier caliper accuracy error is 10 microns. So this 3D scanner will give a different reading from this vernier caliper, about 20 to 40 microns. The Sermoon X1 is very different from this 3D scanner in terms of the accuracy error. For the 7 lines, every time I measure, it gives the same reading as this vernier caliper. So it's more accurate than this 3D scanner. So who's going to believe that the company that make Ender 3 printer in 2018 for $200 is making $6,000 laser scanner in 2025? And this is the most expensive product from Creality. The cable that comes with the X1 is very long, 4.5 meters. So they need to have a signal booster here in the center of the cable. So the first time that you use your 3D scanner, you have to calibrate it. Even though it has been calibrated from the factories, it can move from the impact during the transportation. So to reclaim the accuracy from the factory, so you need to recalibrate it. Each scanner will come in a pair with that calibration board. It's not interchangeable, and when you use it in the different room temperature, I would say more than 5 degrees, you should recalibrate. Okay, this is the Creality Scan 4. You can click it on the calibrate and scan the QR code in the back side. It said right here, incorrect calibration board model. You need to type it, incorrect calibration board. Okay, so Creality told me that they mixed up the board. This is the incorrect board. So I cannot do the calibration during this test. It was calibrated on 11th November, so it's not long ago. So I hope that during the transportation, it's not been to an impact. 60 micron over 150 at 26 degrees Celsius. Okay, this is the scale bar. Additional accuracy control of this device other than the calibration board. It's made from the carbon fiber. In theory, it should have a very low thermal expansion. It's quite stiff. So this scale bar has a known dimension. They already record the actual dimension of this bar in the barcode. So when you place it on the scanning scene like this, it's going to scale your markers during the global marker scanning. So you should place it in the X and Y axis like this. So after you do the global marker scanning with the scale bar, you can remove it because it's already scaled the markers on this turntable. They only give you 2 bars. It will tell us a number here, 3, 4, and this one is 1 and 2. It's going to detect automatically, and it will know the size between these 2 dots. I'm going to do a global marker scanning. Click on photogrammetry. It's not paired with the scanner, so you can use other ruler to do this. So it's scan 1, 2 is scan. Click on OK. Next, you need to do the global marker scanning. So when you scan with the global marker, you can't spin the table. You need to move the scanner around because the ruler is not going to move with the turntable. Click start to scan with the turntable. So now let's see the first ruler, 3 and 4. Now I see the second ruler, 1 and 2. So now it's all done. I'm going to click on white cloud, click on OK. Then you can remove the scale bar. I'm not sure about Z-axis, but X and Y scale. I'm going to start scanning with the 7 lines, 0.2 millimeter. Okay, next I'm going to do the same with the cross line, with and without the scale bar. You can use single line to scan surface that is not a whole flat surface, but I don't recommend it. But I do this just to find the accuracy. Okay, next I'm going to do a drifting alert test with this 2 meters aluminum bar, and I'm going to compare it with and without using the scale bar. I put this into Cloud Compare and I measure the point just right above the sticker mark that I put on. So it's the same spot when I measure with the vernier caliper. To my surprise, when using the scale bar, the error is higher than using no scale bar. So what I understand is calibration board, it gives higher accuracy than calibration with the scale bar. And this will be the result from the single line. The error from scanning with the scale bar is higher. The accuracy error from the Sermoon X1 is very low. It stands out from the group, just 2 microns from the 7 lines. And the accuracy error from the Sermoon S1 in the single line is much higher than the X1. I think it's above 50. I didn't put the number here. And when you do a multiple measurement of the same object in the same room temperature, the lab test and the Sermoon S1 is to give plus or minus 10 or 15 microns leading. It has lower precision, so when you measure the same thing many times, it's going to give you a different reading. But for the Sermoon X1, it's quite different. When I measure this 3 or 4 times, it's going to give you the same reading every time, single digit micron levels. When you look at the aluminum profile scanning 2 meters long, the drifting error when using the scale bar is higher than not using it. Until this point, the Sermoon X1 give a lowest drifting error in my test, 9 micron per meter. So if you scan 4 meter, you're gonna have less than 40 microns of the drifting error. But if you do the same with the Metro X, you are going to have 4 millimeter of the drifting error. The accuracy from the Metro X is less than using the measuring tape. I'm going to measure the working distance from the object. I think it's somewhere around 30 to 40 centimeters, I guess. Yeah, it's about 33 centimeters, same as the Sermoon S1. Power line is 20 centimeters. So when the scanner is closer to the object, it will give you higher detail. Same thing when you do a video camera recording, 33 centimeters. Okay, for the marker spacing on the flat surface, now I'm spacing it for 21 centimeters, same as the Sermoon S1. This is 21 centimeters, 22 is still tracking, 23, 23 is still tracking. Let's try 24. I think 24 will be the limit. Okay, this should be the same for the single line. It's still a 24 centimeter spacing. Yeah, 24 still can track. Power line for the S1 is 10 centimeter, and for the Raptor, it was 5 or 6 centimeters. The spacing. Okay, 10 is still tracking. 12 still tracking. Yeah, 13 is the limit. Okay, in conclusion, the X1 has the same working distance as the S1, but it has larger FOV in both 34 lines and the 7 lines. So this makes the marker spacing wider than the S1 and twice as wide as the Raptor series. Okay, next I'm going to do speed test, scanning this cutting board. Scan the marker first. So that will be 66 seconds. Okay, next I'm going to do with the parallel lines. So it's 3 minutes 10 seconds. The Sermoon X1 is the fastest laser scanner I have ever tested. In 34 lines mode, it's 20% faster than the S1, and in the 7 lines mode, it's 40% faster than the S1. And if you look at here, the X1 in 7 lines mode is even faster than the Raptor X in the closed line mode. Okay, next I'm going to test the precision of the 3D scanner using an egg. I make 3 scans and then I merge them together. Because the egg is not perfect circle, it will be 50 microns out of roundness by nature. So if the scanner can detect this 50 microns out of roundness, it can merge automatically in the software. Okay, so I'm going to start with the parallel lines. I'm going to merge them together. Let's see if it can merge automatically. See here, it's merged without any seam lines. Okay, scan 456, the scan data from cross line 456. Yeah, it can merge. No seam lines. Cross line and parallel line has the same precision. Okay, next I'm going to do a resolution test by making a 3D scan of this owl using 0.1mm resolution, and then I'm going to compare it with the Raptors and the Sermoon X1. I'm going to make only 2 scans. Okay, here's the result. X1, S1 and the Raptor. X1 has noise when I scan with the owl. I cannot see the difference on the resolution from the front. If you look at the eyes, they are very similar. Let's take a look in the back. Okay, this will be X1, S1 and the Raptor. Yeah, I think they look similar. But if you look at the scan from the MAF3, it has higher resolution than the Raptors. I don't see any improved resolution from the X1 over the S1. The resolution is the same, even though it has 3 megapixels camera. Okay, so I also make a EUC bumper scanning that I used in my previous video with the X1, and then I slice it for measuring for the accuracy. Okay, let's compare this to the Raptor and the Sermoon S1. You can see that it has outstanding accuracy, and for the resolution, yeah, I can confirm that the resolution is about the same. The performance of the single line laser, the scan ability for scanning deep pocket is about the same. It's not bare. Okay, let's compare the result. This one from the cross line laser, NIR medium mode and NIR small mode. The cross line gives a very accurate color. This is exactly the same color as the model that I scanned. And for the infrared, the color is wrong. NIR in the medium mode has a color shifting. The mesh quality, I'm going to remove the texture. In the small mode, I fuse it with 0.15mm, and for the medium it's 0.2. That's already the maximum resolution. And for the cross line, it was fused at 0.15mm. But the tracking performance is very impressive for the infrared, but the result is not that good. Okay, let's compare the result with the S1 and the Raptor Pro. It's not that different. I can't see anything different. And I can see there's a bit more noise from the X1. Raptor Pro versus X1. Nothing different. I think I make 2 scan and merge, so it's more complete. This one is a single scan. Nothing different. What about Raptor X? Nothing different. MAF3, yeah, same. Okay, this will be the last test for this video. Okay, in conclusion, What is the difference between the X1 and the S1? Why should you pick X1 over the S1? Reason number one is that the X1 has an exceptional accuracy. It can replace lab grade 5 measuring tools, micrometer, ball gauge, height gauge, and those two are already more expensive than the X1. Okay, let's talk about the speed. 4 months ago, S1 is the fastest laser scanner from Creality. It's a lot faster than the Raptor with 90 frames per second, but this time X1 is faster. Even though in the website, the specification, they say that X1 has a similar speed to the S1, but in fact it's faster, 20% faster in cross-line mode and 40% faster in the 7-line mode. So now the X1 in 7-line mode is even faster than the Raptor X in 34 lines mode. And in 7 lines mode, it has the same marker spacing as the Raptor in the cross-line mode. So it doesn't use a lot of markers. It uses less marker than the S1 and a lot less than the Raptor. Okay, what's the disappointment for me between the X1 over the S1 is that I thought that it was going to give a higher resolution when I scan the owl and a small part because it has 3 megapixels depth camera comparing to 2 megapixels depth camera from the Sermoon S1. Disappointment number 2 over the S1 is that the single line mode. I thought that it will scan better than the S1. S1 is fine for a single line. It's not perfect, but it does the job. It works when scanning deep pocket. I thought that the X1 with the new projector will perform better than the S1, but it's not. When I scan the deep pocket, it's exactly the same as the S1. In my opinion, for many users, accuracy performance of the X1 is already justify the price. Many engineer work is required that kind of accuracy for work, and it's a lot cheaper than the lab grade measuring tools and faster to measure than you sending the part into the metrology lab and wait for the report. So this will shorten the time for many engineers in the design work and inspection. Okay, for most users, I think S1 or even the Raptor original would be enough for your work, but if you are engineer and you need accuracy, then it's probably the cheapest 3D scanner in the market right now that can measure with this high accuracy for $6,000 US. Okay, here's my first review on the X1. I will showcase more of it in the next project, scanning the engine parts. Thanks you guys for watching. I'll see you in the next video.